Okay, so today I'm going to discuss the homework 2 under the properties of plane areas. So this week onward, I'm going to give you a solution discussion, right? This actually, instead of giving you a document, I'm going to discuss the homework and provide it as a video. Okay, we will start for the day 2 homework. First question is 9.32. So you have to do the 9.32. 9.32. So 9.32. This is the figure for 9.32, and we have to find moment of inertia. Moment of inertia and radius of gyration. Okay, radius of gyration with respect to x-axis. That is the question. So if you look at the given area, right, there are different ways to, so you have to use the composite method. There are different ways to handle this. Actually, I went through some of the solutions submitted by students also. So one of the method that I suggest is we can consider the biggest rectangle of them all, right? And the given xy coordinate is the centroid of the biggest rectangle. Therefore, we can write down the moment of inertia of the biggest rectangle, right? For the biggest rectangle that I have in red color, moment of inertia will be 1 over 12 base. Okay, base is now 2 plus 2 plus 1, 2 plus 2 plus this half now therefore 5, 1 over 12 b b h. H will be 6, right? B h cube. So this is the moment of inertia of the biggest rectangle. From that, we have to subtract the moment of inertia of the two rectangles available. This green color portion and this yellow color portion. We have to subtract their moment of inertias. To do that, we have to use the parallel axis theorem. We have to use the parallel axis theorem, right? So if you know parallel axis theorem, so we have to use the parallel axis theorem to find Ix of the green color one and the yellow color one. So I will put a bracket. Here I am going to write down the Ix of the green color one by using parallel axis theorem. Area is 2 by 4, 8, right? And the distance to the centroid is midpoint, no, 1 plus 1, 2. 1 plus 1, 2. So 2 squared, a y bar squared plus the centroidal product of inertia, centroidal moment of inertia. So it is 1 over 12. The base is 4. Okay, height is 2. Height is 2. 1 over 12 bh cube. Okay, that is the green color part, right? I will close the bracket, and also we have to subtract the moment of inertia of the yellow color one. The moment of inertia of the yellow color one, again we have to use the sorry, parallel axis theorem. Okay, the area is 4 by 1. Okay, this is 4 by 1, therefore 4 into centroidal distance is 1.5. It is minus 1.5, but we have to take the square, therefore 1.5 squared plus 1 over 12, 1 over 12 base into height. The base is 2, height is 1, right? 1 over 12 bh cube. So by evaluating this one, we can find the product of inertia of the moment of inertia of the answer is 46. Answer is 46, right? So when I'm doing this alone, there are 32. Answer is 46. So there may be some mistakes in my calculation. Base is 4, right? Base is 4. For the second one, base is 4, right? Base is 4. 1 over 12. Base is 4. Height is 1. Then it is 46. Right? So that is the Ix of the figure 9.32. We also have to find the radius of gyration. So you know that radius of gyration is square root of Ix over area. Ix is 46. We have to find the area. The biggest triangle, rectangle is 5 by 6, no? 5 by 6. And we have to subtract the green color one. It is 4 by 2 minus 4 by 1. Okay, therefore this is the value. It is 1.592, something like that. In the answer sheet we can check this 1.32, 1.599. The unit is in inches. So I will try my best to reduce the length of this discussion. Okay, then we will move into the next question. Okay, second question that you have to try is question 34. Okay, I have given 34. It is a straightforward question actually. In 34, we have to find the 34 moment of inertia. Okay, moment of inertia and radius of gyration with respect to y-axis. Y-axis, that means IY, right? So if you look at the same three rectangles, right, they are so the given xy coordinate system passing through the centroid of all these three rectangles, no? The biggest rectangle and the all other two. Therefore, we can use the equation directly. For a centroidal, it is, we know that 1 over 12 bh cube. So we can use 1 over 12 bh cube. Actually, we have to edit the previous calculation. No need to use the parallel axis theorem. First one is given by 1 over 12 hb cube. Therefore, cube of 5 and just h and 1 over 12 ph cube for cube of 4 and 3 and 2, right? This is 1 over 12 4 cube of 4 1 over equation is 1 over 12 hb cubed. No? This is 1, right? And by equating, we can obtain 93.2, 46.5. Answer is yes, 33, 34, 46.5. And we have to find the radius of gyration. So we can use our previous calculation. Here, same area, uh, 34, 46.5. We have to just put 46.5. Then we can end up with the solution 1.607. Okay, now we have completed 2 questions. Okay, we will move into 9.36. Okay, 9.35. In the case of 9.35, we have to find uh, both ix and iy. First, we will find ix, right? Mm, So we can consider this. Actually, we can consider half of the diagram, right? The part above the x-axis, it's a rectangle, red color rectangle and a semicircle. So by adding these two, we can find the, okay, I am going to calculate ix for half of the diagram, So later, then I'm going to multiply the result by 2. Then we can find the total one. So for the rectangle, it is given by 1 over 3 1/3 bh cubed. B is now 2a. B is 2a. In calculator, we can use symbols, right? B 1 over 3 1/3. Base is 2a. Height is a. Alpha a. Okay, a cube. Later, we can put, for example, if you press the calculate button now in the calculator, if you check calculate button, you have to enter value for a and press equal sign. Then you can find the value for the particular variable a. Okay, that's the method that I'm going to use. So for the red color one, it is 1/3 bh cube. 1/3 bh cube. Then we have to add the product of ix of the semicircle. When it is a semicircle, with respect to diameter, with respect to axis passing through the diameter, we know that the moment of inertia is given by 1 over 8. 1 over 8. It's a semicircle. 1 over 8 phi r to the power 4. Now r is a, phi r to the power of 4. Okay, but this is with respect to the red color axis. So what we want is not the red color axis. What we want is the black color axis, but we cannot directly move it. We have to go to the centroid, and from the centroid we have to bring it back to the uh, any other coordinate system. So centroid of the rectangle, centroid of the semicircle will be somewhere here. So we have to subtract a y bar squared from this value, a y bar squared from this value. Then we can find the centroidal value, a y bar squared. Okay, area is given by it's a semicircle. No? Area is given by half half of phi r squared, half of phi r squared, squared, half pi r squared into a y bar. Y bar is we know 4r 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 over 3 5 square of it. Now what we have calculated is this term, right? We have subtracted no ay by square. Therefore, it is the moment of inertia with respect to blue color axis. Again, we have to add ay by square term. Ay by square term. Now y bar will be this one. Initially, this will be the y bar. We use this one. Then again we have to add this part. Then we can find the value for the black color coordinate system. Okay. Again it is ay by squared, same a, half phi r, r is a now, half phi r squared into y bar squared. So y bar is same value, 4r over 3 5 plus a, okay, plus a square, right? So I have subtracted one ay bar and again added another ay bar. Then close the brackets. Then we can find the moment of inertia with respect to x-axis. We have already multiplied by 2. No? So it is answer is not given in the book. Answer should be 1.267 into 10 to the power 6. Okay. We have to repeat this for y-axis also with respect to y-axis. I think when it is with respect to y-axis, value of semicircle plus another red color one we can consider. Again 2 times 1 over 12 now. 1 over 12 base is base and h interchange now. When you are doing previous calculation, if you press the calc button, then it will ask the value for 20, value for a, then you have to put 20 or whatever the value, then it will produce the answer, right? If you just press the equal button, it will be calculated for the value already stored in the computer, right? Okay, Iy 1 over 12 bh cubed, 1 over 12 bh cubed, a into 2a, into 2a cube, right? And we have to add the value for semicircle. When it is semicircle, it is 1 over 8 pi 5 5 r to the power of 4. So we can calculate 20, and this will be the answer. Okay, I'm not going to do 36. Okay, 36. I did similar question in the class also. 36 and 39 was discussed in the class. Therefore, I'm not going to repeat it. Then I'm moving to the question number 42. In 42, we have to find the centroidal IX and IY. Centroidal IX and IY. Okay, parallel to and perpendicular to AB. So the easiest coordinate system that we can select is the easiest coordinate system that we can select is uh, x-axis like this and y-axis like this. Then easy to do the calculation. We can calculate ix, iy first. Then we can use the parallel axis theorem for the whole one and find the ix bar, iy bar. That is my objective. Okay. So first I am going to find uh, ix. First I am going to find ix. Okay. To find ix, we can consider a composite method. Consider sum of triangle and a rectangle. For the rectangle, it is given the calculator. You can see 1/3 bh cube. 1/3 base is 12, height is 22 bh cube. For the rectangle, that is, then we have to use the parallel axis theorem, because one centroidal moment of inertia is 1/36. B is 24. BH is 18. Right? This is 1/36 BH cube. This is the centroidal value. It's a centroidal value, no? That's a centroidal value. So we have to use parallel axis theorem and find it for the AB axis. Therefore, we need to do the correction. We have to add a y bar squared bar. A y bar area is 12 into 22, not 12 into 22. Area is 0.5, half into base into height. Base is 24, no? For the rectangle, base is 24, height is 18. This is area. Then y bar. Y bar is given by 22 plus 6. 22 plus 6 square. 22 plus 6 is square. So this is the value for ix. This is the value for ix. So we have to keep it, because we don't want to find ix, right? But we want this ix bar. Normally in calculator, we can store values. For example, let's say we did 12 plus 5, then equal sign, it will be 17. No? Then you can press the store key here, store. Then you can select any variable that we have, for example, store, then press A. Then answer is stored as variable A. Okay, later if you want, then you can use help or you can use recall, but no, you can alpha A, then A will be the stored value. So I'm going to use that method. Here we did the calculation. No? This is ix. No? So I'm going to store ix as A, right? Then we can refer it later. And we have to find y bar. We have to find y bar of send y bar. That is 12 into 22, the area of the rectangle into centroidal distance 11 plus 0.5 into 24 into 80. That is the area of the triangle into centroidal distance. So 22 plus 6, 22 plus 6, it will be 28. Then divided by the whole area, 22 into 12 plus 0.5 into 24 into 18. Okay, then we can find the uh, I bar of the whole thing, 18.65. So I'm going to store it as B, and we need to find ix bar. No? So ix bar is equal to uh, ix, that means previous value, then area of the whole thing, 22 into 12 plus 0.5 into 24 into 18. Okay, here y bar is b now. I have saved it as b squared plus unknown value, we can put x. Then you can press the solve one, solve a b, solve for x. This is 0.5, 0.5. Okay, try to do it as a value of a, I think. I can change it. Yes, final answer is 48.9 into 10 to the power 3. Okay, 48.9 into 10 to the power 3. This is Ix. The calculation Ix bar. So y bar is same as Iy bar is same as Iy. No? Therefore, if you found Iy, it is same as Iy bar. So I'm going to find Iy bar. For the rectangle, it is 1 over 12. So I'm going to consider half of the diagram, and multiply it by 2. Okay. With respect to y-axis, it is symmetrical, so I'm going to consider only half of it. Then going to multiply the result by 2. Half of 2 times for the rectangle 1 over 3, base is 22, height is half of 12, 6 dh cube, two times half of 1/3 b 22 into h is 6 dh cube. Something wrong with my calculator. 2 times 1 over 3 1 over 3 base is 22, height is 6 dh cube plus for the triangle we have only considered half of the triangle. It is 1 over 12. 1 over 12 base is now 18, something like this, and height is 12 cube 12. Okay. That we can find the value 42, 8.35 into 10 to the power 3. Yes, that is the given answer. Okay, here we calculate 42. We have to discuss one more question. Okay. Okay, we will move into the 45. Okay, in the 45, we have to find the polar moment of inertia with respect to O and with respect to the centroid. First, we will find polar moment of inertia with respect to O. Okay, so there's a rectangle. For this rectangle, we can find polar moment of inertia by adding Ix and Iy. Okay, by adding Ix and Iy. So Ix is 1 over 3 into base is 50 and height is 100. This is the value for Ix plus Iy. Iy is also 1/3 bh cubed. 1/3. Now b and h will be changed, right? Therefore 100 into 50 cube. So this is the Ix plus Iy. 1/3 bh cube plus 1/3 hb cube for the yellow color plane area. So this is the I naught of the yellow color plane area. And there's another rectangle whose value is also same. Therefore, twice of this. Okay. Then only change is xy coordinates change. Anyway, Ix plus Iy will be same value. Therefore, twice of this. Okay, 2/3 into that value. For that one, we have to add the polar moment of inertia of the quarter circle. For a circle, polar moment of inertia is half. For a semicircle, 1 over 4. Therefore, this will be 1 over 8. 1 over 8, 5 r to the power 4. 5 r to the power 4. R is 100 to the power of 4. Okay. By pressing equal sign, we can obtain the value for I naught. 45. I naught is 80.9 into 10 to the power 6. So that is it. Then we have to find the centroid. We have to find the centroid of this plane area, and we can use the parallel access theorem in polar form to find the IC. Okay. So first thing is we have to find the centroid. We have to find the centroid. I'm going to store this answer. We have to find the centroid. For the two rectangles, we know we have to follow the composite method. No, to rectangles we know the centroid. For the quarter circle, we have to find the centroid. For the quarter ellipse, again x bar y bar will be 4r over 3/5. For a semicircle, 4r over 3/5. Right? Same value will be used for quarter circle also. If you want to prove that, you have to consider circular sector that you have used in A level. Circular sector. Circular sector I think it is 2r sin alpha, 2r sin alpha over 3 alpha. This is alpha, right? This is symmetrical. Therefore, this is the symmetric axis. So, when it is a semicircle, when it is a quarter circle, alpha is 5 by 4. 5 by 4, then we have to use 2r sine 5 by 4 is 1 over root 2, 3 sine 3 5 by 4. Okay, it is the direct distance. No, it is direct distance. It will be the direct distance. Then again, if you multiply it by root 2, you can find x bar and y bar. If you have to find x bar and y bar, you have to again multiply, because the equation gives the direct distance for the polar coordinate. Okay, therefore you have to multiply this result by root 2, then you can find the value 4r over 3/5. 4r over 3/5. So I'm going to find the area. I'm going to find y bar. So cos 100 into 50. Okay, its centroid is half the distance now, 50, plus for the 0.25 times 5 into 5r squared into 4r over 3/5. 4r over 3/5. That is the y bar That is the y bar for quarter circle. Then again 100 into 50, 5000, but its y bar is negative now, minus 25, and divided by the total area. This is 5000 plus 5000, 10,000, 10,000 plus 0.25 times 5r squared. 5r, r is 100. So this is the y bar. $25.67. It is the centroid of the whole thing, right? Centroid of the whole thing. And this y bar, this is the y bar that we have calculated. So both y bar and x bar are same, right? Because it's symmetrical situation. I'm going to store it in the. Now we have to find I centroidal. So we have to use the parallel access theorem in polar form. Parallel access theorem in polar form. Then we have to use the direct distance from O to. We have to use the direct distance. Direct distance here to here is fixed, right? So A is the initial value. A is the I naught. A is I naught, right? A is I naught minus A R squared. A is 10,000. 10,000 plus quarter, no, 0.25 times 5 R squared, right? Into, but I enter this A Y A R bar squared. R bar is not just B, right? B times root 2. But we want is the black color distance, no? Black color distance. Black color distance, no? What we have found is the red color distance, x bar, y bar. What we want is the polar coordinate, not the Cartesian coordinate, right? Then we can end up with 57.4 into 10 to the power 6. Okay, so you should be able to manage rest of the questions. Okay, in addition to questions that I discussed, there are some other questions. So spend some time and try to complete all the questions. Okay, bye bye.